In today's lesson for Pythagoras theorem, we're looking at right-angled triangles. So in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The formula that is used for Pythagoras theorem is c squared equals to a squared plus b squared, where c is the hypotenuse. And if we have a look at our diagram on the right-hand side, c is directly opposite the right angle, which is the longest side of this right angle triangle. So we're going to write the longer side. Now the other two sides, which are A and B, they are our shorter sides. So A and B are the shorter sides. So the square of the value of this side plus the square of the value of this side gives you the square of the value of the hypotenuse, which is the longest side. There are two videos that I've linked in the description, and I'd like you to watch that because those are really good videos. They're very simple videos for you to understand why this actually works. Now, you can pause the video before I can move on to the examples so you can watch those other two. Otherwise, I'll move on now. So in exercise 103, we're going to try to find the hypotenuse here. So I'm going to stick in this formula on the side just so that we recall this again and again and again. So what is the Pythagoras theorem for this triangle? Well, our formula firstly starts off with the hypotenuse. The hypotenuse is opposite the right angle, which is there, which is the length y. Okay? Now, y squared, in this case, is equal to the sum of the square of the two other shorter sides, which are x squared plus z squared. So our answer for question 1 is the letter D. Moving on. Question 2. Write Pythagoras' theorem for each right angle triangle. So for part A, if we identify the right angle, opposite that is our longer side, which is the length p. So p squared equals the sum of the squares of the other two sides, which are m and n. For question B, opposite the right angle is our hypotenuse, t. So t is our hypotenuse, we square that, and that is equal to the sum of the square of r and s. So it's r squared plus s squared. Now in C, opposite the right angle, you don't have a lowercase letter there. But what we can do to represent this side is LK, which is from L to K, or KL, using the corners as the vertices that we go from one to another. So we say LK squared, so that side squared, is equal to LJ squared plus JK squared. Okay? In question D, our hypotenuse is the number 5. So we're going to write 5 squared first by itself on the equation, and we'll make this equal to the sum of the other two sides squared, so it's d squared plus 3 squared. For question E, our hypotenuse is 12.5, so we're going to do 12.5 squared first, and that is equal to the sum of the other two sides squared, so that would be the 10 squared plus 7.5 squared. Question F, we've got x, and x is our hypotenuse right opposite the right angle, being the longest side, and x squared in this case is equal to 3 squared plus 3 squared. So the sum of the square of our shorter sides. We're now going to move on to question 3a. Find the value of each pronumeral. So, remember our formula is c squared equals a squared plus b squared, where c is a hypotenuse, so in this case it will be the letter h. So h squared would be equal to 6 squared plus 8 squared. Now what we've got to do here is calculate the value of this. When we put this in our calculator, 6 squared plus 8 squared is going to be the number 100. And now the important step here is to undo that square on top of the h. The opposite of that is to square root each side. So if we square root this side and square root this side, what this does is the square root and the square would cancel because they're inverse operations of each other. So h would equal to the square root of 100, which is the number 10. So that's our value of the pronumeral, and h will be 10 meters. And it would be very good for you to check every single time that you do these kind of questions that whatever you get for the hypotenuse, which is this number 10, has to be longer than the other two sides. So if you made a mistake and let's say you did h equals to 5, well, that doesn't make any sense because this should be greater than these two sides, which are the shorter sides of the triangle. So it's important to look at your answer at the very end when you do this question, in case you've made a mistake here. Right, we're going to move on to question 4. Now for question 4, I should raise that I'm going to do question 5 along with it. Question 4 is asking to find the value of each pronumeral as a surd. So we're going to apply the Pythagoras theorem on this question. So we're going to start off with the hypotenuse, m. We're going to square it and make that equal to the sum of the other two sides squared. So when we do this on our calculators, 17 squared plus 24 squared is going to give me 865. And I should mention that you should always write the left-hand side down as well. And now what we're going to do is we're going to square both sides to undo that square at the end. So that cancels. So the most important part after that is writing m and not m squared anymore. M is now equal to square root of 865, which on my calculator does give you 29 point something. But you know what? I'm going to write this as root 865 first, because the question says write the pronumeral as a surd. So for question 4, they want you to write this as a surd, so usually you'll stop there. Now in question 5, it's said to write anything in question 4 to 2 decimal places. Let me just check that. No, 1 decimal place, I should say. So I'm going to write this as 29.41, and it has more numbers after that. And it's a surd because you can't change it to a fraction. But for question 5, we have to round this to 1 decimal place. So it'll be approximately 29.4, and just don't forget the units, which is kilometers. Okay? Question E. The hypotenuse in this case is the letter D, opposite the right angle. So D squared would equal to 3.4 squared plus 2.8 squared. So 3.4 squared plus 2.8 squared does give me 19.4. And remember if for question 4 they want us to write it as a surd, we square root this and we square root this, so that becomes D now. And so the square of the right hand side simply is 19.4. So we leave it like that. But for question 5, E, we have to square root this answer and get 4.404 and so forth, okay? If it says to give it to 1 decimal place, write at least 2 numbers after that. So I wrote 3, that's 1 more than that, that's good. Now we can round this to 1 decimal place by looking at that second number, and that second number is below 5, so we're going to round that first number after the decimal place to 4, so it's 4.4 centimeters. Alright, let's move on to question 8. So for question 8, we're just going to do the first column. So complete each equation. So question 8 is 24 squared plus 32 squared equals something squared. Okay, what we should do here first is calculate what this actually is. So 24 squared plus 32 squared equals to 1600. I'm just going to write that again. So 1600 or 1600 is something squared. To actually get the number here, all we have to do is square root this number, because this is already a square of some value. So if we square root this number on our calculators, so you type square root and type 1600, we get the number 40, and that 40 belongs here. Question D. 21 squared plus something squared gives me 35 squared. Okay. Well, to do this question, what we're going to do is we're going to write down what 21 squared is, which is 441, plus something squared gives me 35 squared. So that's 1,225. Okay? Then what we're going to do is we can actually solve for this really easily by simply letting what the unknown value is be x, like that. So we're solving for x squared there. So using our knowledge of equations, we can subtract 441 to both sides, like that. And that cancels out this. So that x squared now is 1,225 minus 441, and that's 784. So now the last step that I need to do is to square root both sides. So square root on this side gives me x, and the square root on the other side is 784, and the square root of 784 is simply 28. So the number that actually fits in this gap here is 28. Question G. Now that gap there, that's squared, I'm going to start by writing that as x squared. So x squared plus 24 squared equals 51 squared. And we're trying to find out what is x, okay? So last time what I did was I actually calculated what these are. You don't actually necessarily have to do that. You can just do this. You can do the opposite of adding 24 squared, which is subtracting 24 squared at both sides. We can just do this. So that will eliminate that 24 squared, and that leaves x squared on the left-hand side. So x squared, we're now equal to 51 squared minus 24 squared on the calculator. That gives me 2,025. And our last step now is to square both sides so that we eliminate the square on top of the x. So x is the square root of this answer, which is now going to be 45. So 45 fits in here.